this is Rob. I'm here to do volume with you the easy way. And I also wanted to ask you, what's your best camera angle? Pretty sure down here is not flattering. Is it from top? It's not from the right side where all the white hair is. I go to the left side. So in any event, I'm going to play with Legos. And I'm going to make volume very easy for you. If you can handle area, volume will be a dream. So I'm just going to pick a shape. Probably some of everybody's favorite shape is the square. The square is part of a group of quadrilaterals called parallelograms because it has two pairs parallel. Parallel sides never cross. So if I asked you to do the area of this square, what would it be? So I'm going to use the very convenient dots to be our units. So this is a 4x4 squared, so it's 16 units squared. But I told you that I was going to do volume. Volume is not two-dimensional like area is two-dimensional. It is three-dimensional. So it has a length, it has three dimensions like length, width, and height. So I'm going to build a box. And when you have a box, and I'll show it to you in a second. Here's my box. This is three-dimensional. It has length, width, and height. And the extra levels, I got levels there to get my three-dimensional shape. A little bit out of focus. So it's super, super easy. As you can see, there are a whole bunch of the same 16 unit squared squares in here. There it is right there. Now it's three-dimensional. So if I wanted how much volume is this taking up, I would just take all these squares that I have right here and multiply it. How many do I have? 1, 2, 3, 4, 5. So you get 80. And it's units cubed because it's units times units times units. Anything times itself 3 times gives you an exponent of 3. So that's it. That's the volume of that box. Let's try another box, and then maybe we can come up with a very easy formula for this volume. So I got a different box here. This box is not made up of squares. It's made up of rectangles. Still a parallelogram. So let's take my shape that makes my layers and write down the formula for the area. Parallelograms base times height. Now I want you to measure the sides and tell me the area. So I decided to give these units a name like centimeters so that you can get used to it. So centimeters times centimeters is centimeters squared. So this is 24 centimeters squared if it was just two-dimensional, but it's not. It's got a height to it also, and that height is 3. So my volume would be 24 times 3. 72 cubic centimeters, or 72 cubic units. Here's your next box. It's a skinny box. Maybe you ordered a poster from Amazon. Why don't you check this one out? We'll see how you would do. Let me change it up. This might be hard to see the colors there. There we go. So now you can kind of tell how many layers there are and the shape. And I'm going to flash the answer up. You do it first. This shape is 64 cubic units. How'd you do? So I'll do another shape and then we'll write down a general volume formula. I like general formulas because they relate more to each other. And I have less to remember. I'm the kind of gal that doesn't remember where I park my car, and I need to honk the horn for me to find it. So that trickles over to my math. I'm going to try and make everything very similar, so I only have to remember one thing. That's why I don't use the LW formula, because none of my other formulas have the LWs in them. So I like to use all my formulas with B's and H's if I can. I don't use B's and H's for every single formula, because not everything is like this. Like a circle doesn't have bases and heights. So now I know this is the best I could do for what shape? Now I know there's little pieces here that are missing. Let's pretend that they're not missing. And let's do this shape, which is a triangle. which if you can see very clearly, is half a parallelogram or square, which is exactly why I was talking about the relationship. It is half BH. And in this particular, half is half. Base and height have to make a right angle to each other. I don't care if I have this thing turned like this. My base and my height have to make the right angle. So my base and height happen to be the same number for this one. If you were to get base and height out of order, it wouldn't matter because multiplication is commutative. And this is 8 units squared for the triangle, but it's not two-dimensional like it looks right now. It's three-dimensional because it has a height, and it has a height of 4. There are 4 of those triangles, 4 of those triangles, and that makes my volume of 32 units cubed. Okay? So I've done 4 examples now, 3 boxes in 1 triangle. Triangle is only half the box anyway. So I want you to notice I'm always taking the area of the shape and multiplying by the layers. What you're going to see me write on papers is a general formula for volume that works for prisms. Prisms are shapes where the layers go up in a right angle. They go straight up. It's not like this. It's not all slanted like. It's not like a pyramid. This is not a pyramid. Every layer is the same shape. In a pyramid, when you cut it, you get smaller shapes. It's not slanted, okay? This is a prism. It's straight up. Prisms go straight up. And this stuff will be in my other note video. Oh, let me put that back. So area, I do volume of a prism. Prism. It's got the height has to go straight up. Is the area of whatever that shape is when I cut it into layers. I call it the base shape. I take my triangular box here and I cut it. I get a base shape. And this one was a triangle. The first one was a square. When I cut it, the base shape is in the other one, when I cut it, was a rectangle. So I just say whatever it is, the area of whatever that is, and it's times what I call the big H, the big height. That's different, okay? So let me talk about that for a second. We have, I don't really like the black one. So I have my base and height of the triangle. I have my base shape, and I have my big height, big H, I don't use a little h, to show how many layers there are. That's the height of the box. So this is like my layers. And then you have to remember, base and height are always perpendicular, and I make them different. This height is the height of the box. This height is the height of just the shape, the two-dimensional shape. So let's see if you can do another one. Here is my beautiful Hoosick Valley blue and white. And this is my shape. You can see, I want to see if you can give me the volume. Remember, I know there's little pieces cut off. We're just going to pretend like that never happened. I need you to find the area times the height, which gives you the volume. Go ahead. Remember, base and height have to be the ones that make the right angle. This shape is a triangle, so I did the area formula for a triangle. 1/2 base times height, I got 32. And then the volume is the area of that triangle and how high that's stacked up into layers. There was 3 layers, and then I get 96, and I never wrote units down, so I just calling it whatever units, cube. Although I said cubic units. Okay, so if you really get this concept, you'll be able to handle this one without any help. Let's try it. Okay, I'm going to wait for you. Pause this. Let's break it down. It is a circle. These slices are circles. The area of a circle formula is shaped like a dessert, like pie, is pi r squared. The radius goes from the center to the edge. That's 2 units. I never said anything about rounding, so if I'm going to leave it exact, it's going to still have a pi in it. Not every exact answer has a pi in it because not every shape is a dessert-shaped circle. So my circles have pi's in it. My other questions, if they don't have pi's, they don't have pi's, they don't have circles. So my area is 4 pi. I'm going to substitute that in here for my volume. Because the volume is the area times the height, the three-dimensional height. It goes up 3 layers, so I multiply by 3. I get 3 groups of 4 pi is 12 pi's. And it's units times units times units, which is units cubed. Cubic units for volume, cubic units for volume, squared units for area, linear units for lines, like just centimeters for lines, centimeters squared for area, centimeters cubed for volume. Okay, and there's actually a very specific cylinder formula, which is pi r squared h, but I don't even like to try and memorize it because I don't have to. Oh, it just fell in the crack. Because I don't have to use it, I'm going to use this one. So I'm going to give you another cylinder and see how you do. Do it to it. Show me what you got. Okay, here's my circle. My radius goes from the center to the edge, otherwise known as half the diameter. All the way across is 8, so the radius is 4. Squared makes 16. The pi still stays pi because it's never said to round. And the volume is the area of the circle, which I substituted in, times the height, which was 3. There was 3 of these. And I get 48 pi units cubed. And that's exact, but let's go over rounding for a second. If you put this in the calculator, you get 48 pi exactly. And if you want some magic to happen, press the magic button. We are never going to use 3.14 for pi. You will always use pi for pi, the pi button. Don't round in the middle of a question. If you have to round, you only round at the very end. So let's go to the hundredths place. So I got 150.7964. If I was going to go to the hundredths place, I would underline it. There's work for rounding. I can get you to show work for everything. So we're going to look next door. If it's 5 or more, we raise the score. This is 5 or more. I will raise this score. But if I raise a 9 to a 10, I can't fit it all in one digit because it's 2. So that's going to bump this up from 79 to 80. You better keep that 0 there. It's a significant digit. It shows that I went to the hundredths place. So this is the rounded answer. So I'm going to put my little about. I'm a little Canadian, so it's my about sign. It's an estimation sign. So I just want to do one little more thing that'll help you realize that you can do anything you need with a prism now. Now what would happen if I gave you something a little funkier like this? Legos are so cool. I can do so much with them. Get rid of this now. What would you do now? This is a different kind of shape. What kind of shape is this? What would you call this? It's like the top of a window, you know? So this is how much of a circle? As soon as you say that, you have the new formula. This is half of a circle. So morph what I got here. So this is a semicircle, so I'm going to put a half in there. This is the beautiful thing about an eraser. So I got a half in there. Half of this is this. Now the volume formula hasn't changed, except this isn't a cylinder anymore. This is something else. So I'll just leave the V. I'll change my little note that I put down here. I like to put the shape down here because it helps me remember what's going on, especially when the problems get longer and I start combining shapes, because I can totally do that. I could like add some boxes to this if I want. I can add this to it. If I see this, I can make this called composite shapes, which is coming up afterwards. So I can, and then I would have to do more formulas. So it's very good to label. You'll end up doing longer problems, of course. So the height, I changed the height. I have 1, 2, 3, 4, 5. So I would just change this to 5. This was, and then change my answers down here. But I'm pretty sure you get the idea. Capiche? Now, one more time. What if I did a box? I don't know. Not everything's a box. I don't know what you want to call it. A container. So if I did this, this is now going to change the formula to not half, but half of a half, which is a quarter. So I do a quarter circle. But I hope Legos made your life easier. They make my life easy when they're all nice and put away. Okay, I'll see you guys in the next lesson.